Hi, it's Mr. Moser, and welcome to my podcast on states of matter. Matter exists in different states and can change from one state to another when it gains or releases energy. Solids are the first type of matter I'm going to talk about. So all matter is made out of particles, such as atoms and molecules, and they're in constant motion. The state of matter is determined by how fast the particles move and how strongly they're attracted to one another. So these solids, they have a definite volume and shape because the particles are packed close together and held together by strong attractive forces. They still move, but they only vibrate about a fixed position. So here we have a picture of quartz, and quartz is what we would call a crystalline solid. Okay, so crystalline solids, they're arranged in orderly three-dimensional patterns. And then over here we have this rubber, and rubber is a amorphous solid. So it's not arranged in any type of pattern. So those atoms or the molecules, they're just kind of randomly put together in these amorphous solids, and then in the crystalline solids they have a very rigid structure, like a 3D model that is always the same throughout the whole thing. And that's the difference between the crystalline solids and the amorphous solids. The next one we want to talk about is liquids. And liquids, they have a definite volume, but no definite shape. And the liquids, they just take the shape of their container. So if I had a cup of water, okay, so here's my cup, and it's full of water, red water apparently. But we take that cup of water, and if we pour it into a flask, here, we pour that water right into this flask, it'll fill up that water to a certain level, the 1 cup level. But we could also pour that water into a pan here, and it would just fill the bottom of that pan. So this water, it doesn't have any kind of like definite shape, but it definitely has a volume. In here, 1 cup, but the shape can change from place to place. So just like solids, liquids, their properties arise from the particles that make them up. And liquid particles are held close together, but they don't have enough, and they have enough energy to be able to move past one another. So they kind of flow past each other, which gives water its ability to flow. Water has some other properties like surface tension. Okay, so surface tension makes liquids seem to have a thin film layer across the top of them. And small amounts of water, where we have really small amounts of water, they'll form these spherical beads or drops of dew. So surface tension is what allows this water strider here to be able to walk on the water. The water molecules in there, they're arranged in such a way that they pull together towards a central point, and it causes this surface tension to happen here. You can also float pennies on water because of the surface tension that happens there. So viscosity is different liquids. They flow, and they flow at different rates. So here we have this oil. This is like motor oil or something, and you can see it has this long stringy bead, and it's really thin. It's flowing a lot faster than this honey is here. And we have the honey here coming off there. It flows pretty slowly, and also this molasses coming off of the spoon. You can see that it flows very slowly, as compared to like water or alcohol, which has a very low viscosity, and they flow very, very quickly. So a liquid's resistance to flow is its viscosity. Honey and molasses flow slower than water because they have a higher viscosity. They're more attracted, the particles are, to each other. And the more attracted they are, the higher the viscosity is going to be. So here we have some gases. Okay, gas is the next one we're going to talk about. Gas is matter that has no definite volume or shape. Particles in a gas move rapidly in all directions. Compared to solids and liquids, the particles in a gas are at a great distance from each other. When a gas is added to a container, like we've added it here, here we're adding gas particles into this container, and when we add them into this container here, they're going to spread throughout the container until they're evenly spaced in that container. And that spreading of particles throughout a volume until they become uniformly distributed is called diffusion. Diffusion. There we go. Okay, so here we have this gas that's being added into a container, and it will spread throughout the entire container until it's evenly distributed in that container by diffusion. Okay, so gas pressure, we know that we can pressurize gases. So these little particles of gas, they collide with each other and the outside of the ball. So here we're pumping gas into this ball here, and as it goes in, those little particles they bump into each other, and they're going to bump into the wall here of the ball. And every time that one of those particles hits the side of the wall here, it exerts a small force onto the wall. So we have a force here, and a force is simply a push or a pull. So as it's pushing into the ball here, that exerts a force onto it. After we've put in a bunch and this pushing over this surface here, we start to build up the pressure inside of there. And pressure is the force divided by the total area that it's exerted over. That's our pressure. And then pressure, we measure pressure with an SI unit called pascals. SI unit, and it's used to measure pressure. So here we have this flat ball. When we have little or small amounts of air in here, we have low pressure, and when we have lots and lots of air in this ball here, then we have high pressure. Okay, so let's review what we've learned. First off, we talked about solids, liquids, and gases. Those are the three states of matter. Solids is where they're really packed closely together. It has a definite volume and it has definite shape. So solids have volume and shape. Oops, and an E. Liquids have volume and no definite shape. They take on the shape of their containers. And then gases have no definite volume and no definite shape. Okay. We talked about gas pressure. Because gases have no definite volume and definite shape, we can take those gases and we can pressure them up, pack lots and lots of gas into a container.